Hi guys, today we're going to be looking at A-level further mathematics, October-November 2023, paper 2-2. So we're going to start now. First question is about Maclaurin series. So we need to include the term x squared. So this will be our fx. Let me write it down. Fx equals to ln x plus 2 plus ln x squared plus 5. So we will need to differentiate the equation. So the first derivative would be 1 over x plus 2 plus 2x over x squared plus 5. For the second derivative, it would be negative 1 over x plus 2 squared plus x squared plus 5 times 2 minus 2x times 2x over x squared plus 5 squared. So now let's simplify so that it looks nicer. So we have negative 1 over x plus 2 squared plus 2x squared minus 4x squared plus 10 over x squared plus 5 squared. And we will get, this is the same thing, negative 1 over x plus 2 squared plus 10 minus 2x squared over x squared plus 5 square the whole thing. So for the first term, we would need f0, which is, after we sub x as 0, we will get ln 2 plus ln 5. And we can simplify it to ln 10. So basically we just take 2 multiplied by 5. For the first derivative, when we have x equals to 0, we would get 1 over 2. Because when this is 0, this whole thing would be 0. So for the second derivative, when x is 0, we get 1 over 2 squared plus 10 over 5 squared. So this would be, oh sorry, there's a negative here, yeah? So this would be 3 over 20. So now we just look at the formula booklet, and we know that for Maclaurin series, we just need to use this equation. I'll paste it here. So we can write ln x plus 2 plus ln x squared plus 5 as ln 10 plus x times half plus x squared over 2 factorial times 3 over 20. And the final answer would be ln 10 plus half x plus 3 over 40 x squared. You can write this, but it doesn't really matter. Yes, this will be the final answer for question 1. For the second question, we will need to find dy over dx from these two equations. So we will first need to find for dx over dt and dy over dt. Dx over dt is basically just negative 1 over t squared. And dy over dt is t times e to the t plus e to the t. And we can simplify it to e to the t times t plus 1. So dy over dx is dy over dt times dt over dx. So it would be e to the t times t plus 1 times negative t squared. So this would be negative e to the t times t cubed plus t squared. For part B, we will need to find d2y dx squared in terms of t. So d2y over dx squared is basically the derivative of dy dx times dt over dx again. So we just need to differentiate this again. So this would be negative e to the t times 3t squared plus 2t plus t cubed plus t squared times negative e to the t. And dt over dx is negative t squared. And we would now get t squared times e to the t times 3t squared plus 2t plus t cubed plus t squared. And we can simplify it to t squared times e to the t times t cubed plus 4t squared plus 2t. And again, we can take out the t's here. We can take them out. So we would get t cubed times e to the t times t squared plus 4t plus 2. And that will be the answer. For question 3a, we need to show this equation. So we can first let c equals to cos theta and s equals to sine theta. Because we will be using a lot of cos theta and sine theta, so if we can write it as c and s, it will be way easier. So we can first find for cos plus I sine to the 5. And this would be c to the 5 plus 5c to the 4 times is plus 10c to the 3 times is to the 2 plus 10c to the 2 times is cubed plus 5c times is to the 4 plus is to the 5. And from the Moivre theorem, we know that for this, we can write it as cos 5 theta plus I sine 5 theta. Okay? So now we just need to simplify the right hand side. So we get c to the 5 plus 5i c to the 4s minus 10c cubed s squared minus 10i c squared s cubed plus 5c s to the 4 plus I s to the 5. And now we just want the cos 5 theta. And we see that cos 5 theta is the real part, and I sine 5 theta is the imaginary part. So since we only want the real part, we just need to extract the real part of the right hand side. So it will be this, this, and this. So we can write it as cos 5 theta equals to c to the 5 minus 10c cubed s squared plus 5c s to the 4. I mean, we can see that in this equation, they don't want any sine theta, right? So we need to convert all the sine theta to cos theta. And how do we do that? From the formula booklet, we know that cos squared plus sine squared equals to 1. So we can write all the sine squared as 1 minus cos squared. So now we would have c to the 5 minus 10c cubed times 1 minus c squared plus 5c times 1 minus c squared the whole thing. And we would get c to the 5 minus 10c cubed plus 10c to the 5 plus 5c times 1 minus 2c squared plus c to the 4. And now we would have 11c to the 5 minus 10c cubed plus 5c minus 10c cubed plus 5c to the 5. And the final answer would be 16c to the 5 minus 20c cubed plus 5c, which is exactly what the question wants. For part B, we need to find the roots of this equation. And usually, the question in part B links back to the equation in part A. And we can see that this part of the equation is similar to this, right? So we can first let x equals to cos theta, because they want the roots in the form of cos, right? So yeah, we first let x equals to cos theta, and we can rewrite this equation as 32 cos to the 5 theta minus 40 cos cubed theta plus 10 cos theta equals to sec 2. And now we can see that this part is actually just 2 times of this. So now we can write this thing as 2 cos 5 theta, which I got it from here. So because it's 2 times this whole thing, so I can also write it as 2 cos 5 theta. So 2 cos 5 theta is equals to sec 2, and cos 5 theta is sec 2 over 2. And we know that the base angle would be pi over 4. So we can write 5 theta as pi over 4, 7 pi over 4, and now we add 2 pi into this to get 9 pi over 4, and we add 2 pi to this to get 15 pi over 4, and lastly we have 17 pi over 4, because we just need 5 roots, right? This equation will only have 5 roots. So now we can write theta as pi over 20, 7 pi over 20, 9 pi over 20, 15 pi over 20, and 17 pi over 20. So our final answer for x would be cos pi over 20, cos 7 pi over 20, cos 9 pi over 20, cos 15 pi over 20, and lastly we have cos 17 pi over 20. Okay, and I do realize that in mark scheme, the mark scheme answer is slightly different from mine. It has cos pi over 20, cos 9 pi over 20, cos 17 pi over 20, cos 25 pi over 20, and cos 33 pi over 20. But in the remark section, it also says that this will be the answer, and they also accept equivalent answers. And you can see that I have this 3, I have the first 3 answers, but for this one, it's actually equivalent to 15 over 20. So I have this 3, sorry. And now, these two are actually equivalent if you type it into your calculator. And this is actually equivalent. So don't worry, you can write this or this as your answer. They are both correct. Question 4 is a first order differential equation. So first we need to check if the equation is arranged in this order. Oops. So the order is dy over dx plus py equals to q. So there shouldn't be anything in front of the dy dx, and the y should be at the same side with the dy over dx. And this should be something that does not include the y. So this is in the correct form. So we can start doing it now. So I is basically exponential to the power of integration of p. So in this case, it's integration of 3, and the answer would be e to the 3x. This will be the first step. Second step, we write iy equals to the integration of iq. So iy is e to the 3x times y equals to integration of e to the 3x times sine x. So how do we integrate e to the 3x times sine x? Okay, so I would use integration by parts, but it will be slightly different from what we normally do. So first I write u as e to the 3x and dv dx as sine x. So du dx is basically 3e to the 3x, and v would be negative cos x. So we can now write the integration of e to the 3x sine x is negative e to the 3x cos x plus, it's actually a minus, but then we have another minus, so it becomes plus. But anyways, I'm just going to write it here. So now we see that we need to integrate this. So we would write u as 3e to the 3x, and dv over dx is cos x. So du over dx will be 9e to the 3x, and v would be sine x. So this is equals to negative e to the 3x cos x plus 3e to the 3x sine x minus integration of 9e to the 3x sine x. Let me move this away so that we don't get confused. Okay, now we need to integrate this again. So if I integrate this, then the whole cycle will repeat. So I'm not going to do that, but instead I'll put these two together. So move this to the left hand side, and I will get 10 integration of e to the 3x sine x is equal to 3e to the 3x sine x minus e to the 3x cos x. And now we get the integration of this. So integration of this is basically 1/10 times e to the 3x times 3 sine x minus cos x plus c. So we just need to sub this equation back into this, and we will get e to the 3xy equals to 1/10 e to the 3x times 3 sine x minus cos x plus c. So we have the info that y is 1 when x is 0. So we sub this into it. So we would get e to the 0 times 1 equals to 1/10 of e to the 0 times 3 sine 0, which is 0, minus cos 0 plus c. So 1 equals to 1/10 minus 1 plus c. And c would be 11 over 10. So we rewrite the equation using the value of c. And Now we need to write the equation in this form. So we need to make y as the subject. So we have 1/10 times 3 sine x minus cos x plus 11 over 10 e to the negative 3x. For question 5a, we need to show that m satisfies this equation. So m is the maximum point of the curve. So in order to find the value of x, we just need to differentiate this equation. So we have y equals to x slash square x, and we can write it as x over cos square x. It would make it easier for us to differentiate. So the differentiation is cos square x times 1 minus x times 2 cos x sine x over cos to the power of 4. So we can first look at this term. It's basically slash square x. And now we look at this term, and we get minus 2x sine x over cos x times cos square x. Oh, sorry. Slash square x. Because for this term, we end up having 2 sine x, 2x sine x over cos to the power of 3x. Yes. And 1 over cos square is equal to slash square. So this is how I got this. And I can simplify it. Okay, I'll just write this as 1 over cos to make it not that complicated. So I have 1 over cos square, and now I simplify it to get slash square x minus 2x tan x slash square x. And I can factorize slash square out to get slash square times 1 minus 2x tan x. So now I will equate dy over dx to 0, and I'll get slash square x equals to 0, and 1 minus 2x tan x equals to 0. But we know that this is undefined. So the only equation we get is this one. And let's rearrange it to this form. So we have 2x tan x minus 1 equals to 0. So we have shown this equation. And now we need to verify that the root is in between 0.7 and 0.8. So for x equals to 0.7, we have 2 times 0.7 times 0.7 minus 1 equals to negative 0.154 rounded to 3SF. And for x equals to 0.8, we have 2 times 0.8 times 10 0.8 minus 1 equals to 0.0625 rounded to 3SF. And we can make the conclusion that since there is a change in sign, the equation has a root between 0.7 and 0.8. As you can see, right, this is negative and this is positive. So there is a root between those two numbers. For part B, we need to consider a set of rectangles to show this inequality. So we can see that they want the R to start from 2 and to end with N. So the rectangles, okay, from part A, we know that M is around 0.7 or 0.8, right? So 2 should be from this part. Let's call this 2. So the rectangle should be after this part. So we have rectangles here. Alright. And we know that the sum of rectangles, the sum of areas of the rectangles is smaller than what they give here. So this is usually the integration of the graph. So now we want the areas of rectangles to be smaller. So the rectangle should be drawn like this. Oops. They should be drawn like this, so that the areas of rectangles can never be more than or equals to the area under the graph. Because you see these gaps? This is why the area of the rectangles are always smaller than the area under the graph. So this would be 2. Okay, since we want R to start from 2, right? We want R to start from 2. We need the first rectangle to have the height of 2 sec squared 2. We need this. So this should be the first rectangle. So this is 3, 4, 5, so on and so forth. And towards the end, we would have n here and n minus 1 here. Okay? So we can start doing this. So the sum of areas of rectangles is basically width times height. And for the first rectangle, we have the width, for every rectangle, we have the width of 1, right? You see that the intervals are basically 1. And the height for the first rectangle would be 2 sec square x. Sorry, 2. And for the second one, it will be 3 sec square 3, so on and so forth. So we can write this as 1 times 2 slash square 2 plus 1 times 3 slash square 3. See, I'm not writing the 1 because it doesn't really matter here. All the way up to n slash square n. This is smaller than the integration. Okay, for the areas of rectangles, we have it starting from this line all the way to here, right? So we are estimating the areas here. So similarly, we need to integrate the graph from 1 to n instead of 2. So we need to integrate from 1 to n for this. Okay? And for left hand side, we can just write it as the sum of r slash square r. And r is starting from 2 all the way to n. This is lesser than, so we need to integrate this. We use integration by parts, so u equals to x, dv dx equals to slash square x, and du dx equals to 1, v equals to tan x. This can be found in the formula booklet. This one can be found in the formula booklet. So we have x tan x minus integration of 1 to n tan x, and we sub the numbers into this and get n tan n minus tan 1 minus, we can write tan x as sin x over cos x before integrating. So this would be, the integration of this would be ln cos x. Why is that so? Because sin is the integration of cos, and we can use the ln method to integrate them. So we have again n tan n minus tan 1 minus ln cos n plus ln cos 1. But you can see that they want it in slash instead of cos. So okay, again, slash is basically just 1 over cos, right? So, and for ln, if we have this, we can move the negative 1, we can move this negative 1 to the front to get a minus ln slash n, right? So because of this, we would get a plus ln slash n minus ln slash 1. And yes, we would get this. For question 6, it's about matrix, and we need to find the eigenvalues of P. So if a matrix has the bottom left corner as all zeros, if these three values are zeros, then the eigenvalues of the matrix is basically these three values, 1, 2, and -1. So the eigenvalues, we can just state them, 1, 2, and -1. Part B, we need to use the characteristic equation of P to find for inverse P. So what are characteristic equations? So basically, you can write the eigenvalues in the equation. We can write it like this, and we try to find the cubic equation. So we would get lambda cubed minus 2 lambda squared minus lambda plus 2. This will be the characteristic equation. And we can now sub lambda as P. So we have P cubed minus 2P squared minus P plus 2I. Since this equation is in terms of matrix, we need the I here. The I here is is this matrix. It's the identity matrix. So it represents the 1 in the normal equation. So we need the identity matrix here so that the whole equation makes sense. So now we can divide the equation by P. So we have P squared minus 2P minus I plus 2 inverse P equals 0. So inverse P is just half times I plus 2P minus P squared. And we will need to find P squared before finding inverse P. So P squared is 1 minus 1, 1, 0, 2, 1, 0, 0, minus 1 times itself. 0, 2, 1, 0, 0, minus 1. So we would get 1 minus 3 minus 1, 0, 4, 1, 0, 0, 1. This is the P square matrix. And now we sub back into the equation to find P inverse. So I is the identity matrix. So it's just like this, plus 2P minus P squared. So we just do like a normal plus and minus. So the first value would be 1 plus 2 minus 1. So we get 2. Second value is 0, negative 2 plus 3. We get 1. So I'm just going to write it down. And the final matrix for inverse P is 1, 1/2, 3/2, 0, 1/2, 1/2, 0, 0, -1. For part C, it states that matrix A has distinct non-zero eigenvalues of this with eigenvectors of this tree. So we need to find the inverse of A in terms of small a. So A can be written as P, D, P inverse. And P in this case, you just need to write all the eigenvectors in. So we have 1, 0, 0, -1, 2, 0, 1, 1, -1. And does this look familiar? You can see that it's actually exactly what they gave in part A. So in part B, we already found that the inverse of P is this. So we can just copy it. So the inverse of P is whatever we found in part B. And the diagonal matrix, we need to write it as A half and 2. We need to write it in this sequence. And we just write 0 in the other spots. And since we want to find for A inverse is P D inverse P inverse. So we need to find for D inverse. And the inverse of a diagonal matrix, basically you just take the inverse of these three values. So 1 over A, 2, and half. Then the rest is just zeros. So this will be the inverse of D. So inverse of A is P D inverse P inverse. And I can write it like this. So now we just have to multiply all the matrix together. So let's deal with the first two. So I'll get 1 over A minus 2 half 0 4 half 0 0 -half. And I'll copy the third matrix. And now I'll multiply them together. So I will get 1 over A 1 over 2A minus 1 3 over 2A minus 3 over 2 0 2 3 over 2 0, 0, half. Let's simplify these numbers to make it look nicer. So I have 1 over a, 1 minus 2a over 2a. And this would be 3 minus 3a over 2a. So 0, 2, 3 over 2, 0, 0, 1 over 2. So this would be the answer for A inverse. So for question 7, we have to prove this equation starting from the definitions of cosh and sine. So let's just write it out first. Cosh x, okay, let's use A here because they use A, right? So cosh A is e to the a plus e to the negative a over 2, and sine A is e to the a minus e to the negative a over 2. So let's prove it from the left hand side. So left hand side we have 2 sine square a, right? So 2 times e to the a minus e to the negative a over 2, square the whole thing, and we would get 1 over 2 times e to the 2a minus 2 plus e to the negative 2a. And this would be e to the 2a plus e to the negative 2a over 2 minus 1. And look at this, compare this and this. Basically, we have 2a instead of a, right? So this is equals to cosh 2a minus 1, which is equals to the right hand side. Part B is about integration. So we need to find the area of the surface generated when the curve is rotated through 2 pi radians about the x-axis, and it's denoted by s. So, okay. So since they give us the substitution, let's find for dx du first. So x is half sine u, right? So dx du is half cos u, and dx would be half cos u du. So we need to find for the integration from 0 to 2 over 3, right? So let's find for u when x is 0. So x is 0, half sine u1. So sine 0 is 0, so u1 is 0. And when x is 2/3, we find for u2. So u2 is sine inverse 4 over 3. And from this, we can find for the value of inverse sine. So u2 is ln 4 over 3 plus 4 over 3 squared plus 1, start the whole thing. And u2 would be ln 3. So now we can start doing the integration. For the area of surface, we have the formula of S equals to the integration of x1 to x2 2 pi y dy over dx squared plus 1. And in this case, we can take the 2 pi out. And in this case, x1 would be 0, x2 would be 2/3, and y in this case is x squared. Dy dx would be 2x. And this would be the equation. So we can start substituting x as half sine u. So 2 pi integration, u1 is 0, u2 is ln 3. X squared would be half sine u squared, and 2x is sine u, but there's a square here, so sine square u plus 1, set the whole thing. Oh, and remember that dx is half cos u du. So we times half cos u du. So now we can simplify it to pi over 4, integrate it from 0 to ln 3. Sine square u, okay, sine square u plus 1 is cos square u. And now we can see that this whole thing is basically sine u cos u squared. And from the formula booklet, we know that 2 sine x cos x is actually sine 2x. So we can write this, oops, we can write this as half sine 2u squared du. And sine 2u okay, we have just proven that 2 sine squared a is equals to cos 2a minus 1. So sine squared a equals to cos 2a minus 1 over 2, right? So we can use it here. So we have pi over 4 integration of 1 over 4 times cos 4u minus 1 over 2. Because this is already 2u, we need this to be 4u. So pi over 32 times the integration of cos 4u minus 1. So this would be 1 over 4 sine 4u minus u. And now we just sub these figures in, and we would get pi over 32 times 1 over 4 sine 4 ln 3 minus ln 3. Because sine 0 is 0 and this is also 0 when I sub 0 in, so I'm just going to ignore them. And how do we find for this value? Remember, we can use this definition. So this is e to the 4 ln 3 minus e to the negative 4 ln 3 over 2. So this can be written as 3 to the 4 minus 3 to the negative 4. And the final answer would be pi over 32 times 820 over 81 minus ln 3. Question 8 is a second order differential equation using the substitution method. And the easiest way to prove these equations, right, is basically we find the derivative that the questions want in the final equation. So they want it to be in dv dx, right? So we have v equals to y to the 4. So we need to find for dv dx. So we treat y as one of the variables also. So since we don't have x, we would just write 4y cubed dy dx. And the second derivative is we treat these two as two variables. So we have 4y cubed. The differentiation of dy dx is d2y dx squared. And the differentiation of 4y cubed is 12y squared dy dx. So now this is equals to 4y cubed d2y dx squared plus 12y squared dy dx squared. And we can see that this part is actually this 4 times of this, and dv dx is actually 4 times of this, and this is just this. So we can write the original equation down first. So y cubed d2y dx squared plus 3y squared dy dx squared plus y cubed dy dx plus y to the 4 equals to e to the negative 2x. So we see that this part is similar to this. So it's actually 1/4 of d2v dx squared. And this part, it's similar to this. So we have 1/4 of dv dx, and y to the 4 is basically just v. So we have changed dy dx into dv dx form, and we just multiply the whole equation by 4 to get the final equation. So this is actually what the question wants. For part B, we need to find y in terms of x. So let me just copy down this equation. Okay, now we can start doing. So for the left hand side, we change it into this form, and we find for the values of m. So m is -12 plus minus sub 15 over 2i. And the complementary function will be in this form. So we just plug these values. So -12 would be in this part, and sub 15 over 2 would be in this part. When the root of this equation is an imaginary number, we have the complementary function in this format. So the particular integral would be, okay, since they have e to the minus 2x, and CF doesn't have e to the minus 2x, they only have e to the minus half x. So we can write the particular integral as v equals to a e minus 2x. So dv dx would be -2a e to the 2x d2v dx squared will be 4a e to the 2x, e to the minus 2x. So now we can put all this into this equation. So we have d2v dx squared as 4a e to the minus 2x, dv over dx as minus 2a e to the minus 2x plus 4v. V is now a e to the minus 2x, and this is equals to 4e to the minus 2x. So we simplify it and get 6a e to the minus 2x equals to 4e to the minus 2x. A in this case would be 2/3. So we can now write the equation in this form. So we have, okay, now the equation can be written in this form, which is complementary function plus particular integral. So we have e to the minus half x times a cos sec 15 over 2x plus b sine sec 15 over 2x plus 2 over 3 e to the minus 2x. So this is the complementary function, and this is the particular integral. So we can differentiate the whole equation. E to the minus half x times negative sec 15 over 2a sine sec 15 over 2x plus sec 15 over 2b cos sec 15 over 2x minus half e minus half x a cos sec 15 over 2x plus b sine sec 15 over 2x minus 4 over 3 e to the minus 2x. So now we can use the values given. When x equals to 0, y equals to 1, and dy dx equals to negative 3 over 8. Since our equation is still in v, we need to find the values of v and dv dx in each case. So when x equals to 0, y equals to 1, dy over dx equals to negative 3 over 8. So v is y to the power of 4, so it's 1 to the 4, which is also 1. And dv over dx is 4y cubed times dy dx. So 4 1 cubed times negative 3 over 8, and this would be negative 3 over 2. So we just sub back into the equations. We can first sub into this equation, the first one. So we have 1 equals to e to the 0 times a cos 0. Sine 0 is 0, so I'll just ignore it, plus 2 over 3 e to the 0. So 1 equals to a plus 2/3. A is 1/3. And now I'll sub these values into the second equation. So I have negative 3 over 2 equals to e0 sec 15 over 2b cos 0. Same thing, because sine 0 is 0, so I'll just ignore it. Minus half e to the 0, 1/3 cos 0, minus 4 over 3 e to the 0. So we have negative 3 over 2 equals to sec 15 over 2b minus 1 over 6 minus 4 over 3. So sec 15 over 2b would be 0, b is 0. So we can now write the equation as v equals to one-third e to the negative half x cos sec 15 over 2x plus 2 over 3 e to the minus 2x. And v is y to the power of 4. So we can copy this first. We need to make sure that y is the subject, so we have y equals to this whole thing to the power of 1 over 4.